Hello, everybody. Welcome to transformation. So, this is a topic that you guys learned about in eighth grade. We're just going to kind of quickly review three of the four transformations you guys talked about. The first one is translations. When we translate something, we're literally just sliding the shape along the graph. Okay. So, this first one wants me to move the shape 4 units to the left and 2 units down. So to do this, it's super complicated. You literally just from each point go 4 to the left and 2 down. So 1, 2, 3, 4, 1, 2. There's my new F. And to show that it is my new F, the point F, right? I put a little apostrophe next to it. That means prime. Okay? It's F prime. That means it's been a transformed shape. It has moved 4 left and 2 down. And I just do that with each shape. E, 4 left, 2 down. There's E prime. And then I think that's a G, 4 to the left. So 1, 2, 3, 4, and 2 down. It's hard to see because the x-axis X was over it. But I think it's a G because E, F, G would make sense. G prime. Okay? So if I connect those dots, there's my new shape. And again, it's the same shape, right? Maybe not with as straight lines because, I don't know. Anyway. So it's the same shape. It's just been slid 4 units to the left and 2 units down. Okay? It's all you're doing with translation is just sliding it along the grid. It's just a counting game, basically. Here we have a shape that has already been translated, and I just need to say what happened to it, right? So I locate my original point. So there's the original point F. It does not have the little, I'm going to zoom in here so you can see it really good. Okay, zooming in. Okay. And the frame rate goes way down when you zoom in. Okay. But you'll notice like this F does not have a little prime symbol next to it. So this is my original F. This is my transformed F. So I'm going to zoom back out now because that's very, very, very far zoomed in. Okay, that's probably good. Nope, it went more. Okay. So all I need to do is figure out what happened from the original one to the new one. It looks like it went 1 unit right and 2 units up, right? I would go 1 right and 2 up. So I could write this a couple of ways. Okay, I could just say 1 unit right and 2 units up. Okay, that's how like these problems were written. Or there's a quick shorthand rule that you can also see it expressed as. So it just says what happens to each ordered pair. So if my original ordered pair is X and Y, if I go 1 right, I'm adding 1 to the X, right? Because 1 is, or to the right, is a positive 1 in the X direction. So I could write that as X plus 1. That's the same as 1 unit right. And if it's going 2 units up, that's 2 units in the positive direction on the y-axis. So I could add 2 to the point, right? And that makes sense because this point is 1, 1, right? This next point over here is 2 and 3. So 1 plus 1 is 2. 1 plus 2 is 3. So I would get that point if I did that math there. So either ways you could write the description or rule for translations. Okay? Reflections. So reflections is where you flip things. It's pretty tough to do. So this shape is flipping over the x-axis. So if we think of the x-axis like a mirror, this U is 1 step away from the mirror, right? If you look at your reflection, it's going to look like it's 1 step away from the mirror as well, but it's going to be on the other side. So how you reflect things is you count to your reflection line or your mirror line, right? So U is 1 step away, and then you count that many steps past it, and that's where your U prime is going to be. And that's all you're doing on each of these. So this T is 1, 2, 3 steps away from the x-axis. So its reflection will look like it's 1, 2, 3 steps past it if you're looking at a mirror. Okay? This W is 3 steps away, so its reflection is going to be 3 steps past it. This V is 2 steps away, so its reflection is going to be 2 steps past it. And if I look at the shape, it's the same shape, but it's flipped. It's like if I flipped it over the line. If I actually folded this paper, it would flip onto that shape right there. Okay? That's all it is. Okay? If you're reflecting across y equals x, that's this diagonal line, right? Actually, that's negative x. I'm drawing negative x for some reason. It's the same idea, but different line. So this is y equals x right here. It's the line that goes up 1 over 1, just hits every box diagonally going through the origin. Okay? So to reflect across a diagonal line has a horizontal and vertical aspect to it, right? So what you're going to do is you're going to count to the line. You can count either horizontal or vertically. So if I count horizontally, K is 1, 2, 3, 4 spots away from the line. When I go the other way, I'm going to flip which axis I'm going. So I went horizontally to it, so I would go vertically away from it. So 1, 2, 3, 4, that's K prime. Okay? Which makes sense because if it flipped across this line, it's going to end up somewhere around there, right? So again, all you do is count either horizontally, and it would be the same way if I counted vertically at first. So I go 1, 2, 3, 4 to it and count horizontally away from it. 1, 2, 3, 4. I get the same point. So you just flip horizontal, vertical once you get to the line. So this L is, if I go horizontally, it's 1 spot to it, and then I'd have to go vertically 1 spot away from it. There's L prime. Okay, which again is about where it is. J is actually on the line of reflection, so it stays on the line. So J and J prime are the same thing. And there is your flipped triangle over a diagonal line. Okay? All right. And then let's do this one. So this one, we have a reflected shape. It looks like it's reflecting across the y-axis, right? Because it flipped this way onto that. So to describe the transformation, you just say what it reflects across. Reflect across y-axis. Okay? Rotating. Rotating is going to be fun. So we can do this just by moving our paper. So if I want to rotate 180 degrees, 180 degrees on my paper would be completely upside down, right? So if I just turn my paper upside down, that's where my shape should be if I rotated 180 degrees. So if this is the x and this is the y-axis, I'm just going to write down the points that I got here. F is now at 1, negative 1. So that's F prime. L prime is at 3 and negative 3. So 3, negative 3. And K is at negative 1, negative 5. So K prime, negative 1, negative 5. Okay? So if I flip it back around, that's where it was originally, right? If I plot these points I just put here, so negative 1, negative 5 was K prime. Okay? 3, negative 3 was L prime. And then the F was 1, negative 1. There's F prime. So that looks just like it did when I rotated the paper, right? I rotate it. That's what it looked like. And that's what it would look like originally. So that's all you're doing. Now, counterclockwise and clockwise, the clock goes to the right. So clockwise is right. Counterclockwise would be going against that. So that's going to the left. So if I turn my paper counterclockwise 90 degrees, I'm turning it on its side. And if this shape goes 90 degrees against the clock, it's going to end up in the bottom left corner, right? So if I turn my paper to the left 90 degrees, there it is in the bottom left corner. We're going to pretend this is now the x and this is the y-axis. And again, we could just look at our points and plot them. So again, I'm just going to write them here real quick. U prime is going to be at -5, -3. Okay, V prime is going to be at -4, -2. W prime is going to be -3, -3. And T prime is -4 and -4. Okay, so I just looked at where all four of those points are, and then when I put it right side up, that's where it is originally. And if I plot those points, they're going to end up in that bottom left corner where it was. That would be rotated 90 degrees counterclockwise. Okay, so this went -5, -3 was U prime. Okay, and then V was -4, -2. There's V prime. And then W was -3, -3. W prime, and T was -4, -4. So there is my rotated shape. You notice like they all kind of like moved over a spot. Like instead of being on the top, U's now on the side. V was on the right. It moved up. So they all just kind of moved up a spot because it rotated 90 degrees. Okay. If it rotated 180 degrees, they'd move 2 spots because it'd go 180 degrees, right? Yeah. So basically, you can kind of tell how much something is rotated to. Like each quadrant on a grid is 90 degrees, right? So if it goes 90 degrees, it's moving 1 quadrant. If it's moving 180 degrees, it's going to be 2 quadrants away. Okay? So that would be 90 degrees away from it. That would be 90 degrees away from it. This would be 180 degrees away from it. Okay. So if I look at this one, write a rule, I just basically need to check like, well, how many quadrants did it move? It moved 2 quadrants away. So it rotated. I just say how much it rotated by. Rotated 180 degrees. Okay. This one, the original shape was right here in this quadrant. Transformed shape ended up in this quadrant over here. So it moved 1 quadrant to the left. Is that clockwise or counterclockwise? So with 90 degrees, you have to say it clockwise or counterclockwise. It doesn't matter with 180 because no matter which way you go, you'd end up in the same spot. But 90 degrees, it's going counterclockwise. It's going to the left. So you say rotated 90 degrees counterclockwise. So you have to say which direction when you're talking about the 90 degrees. Okay? That's basically all you're doing. Okay. Any questions, comments, concerns? Ask your teachers. We're here to help. We want to help, and I'll see you guys out there.